NASA lost a 327 million Mars orbiter because one team used metric and the other used Imperial. In this compilation, we explore how simple measurement errors led to significant disasters. NASA lost a 327 million Mars orbiter because one team used metric and the other used Imperial. The Mars Climate Orbiter launched in 1998. Its job was to study Martian weather and climate. It traveled 416 million miles to get there. The navigation team at Lockheed Martin calculated thrust in pound-seconds. NASA's Jet Propulsion Laboratory expected Newton-seconds. Nobody caught the mismatch. As the orbiter approached Mars, its trajectory was off by 60 miles. It entered the atmosphere too low. The 327 million spacecraft burned up or skipped off into space. NASA's post-mortem was brutal. The error was in the software interface. A simple unit conversion would have saved the mission. It was a typo-level mistake. Space agencies now have rigorous unit checking protocols. But the same kind of interface mismatch still happens in software every day. The Silver Bridge collapsed in 1967, killing 46 people. The cause was a tiny crack in one I-bar. The bridge connected Point Pleasant, West Virginia to Ohio. It was a I-bar chain suspension bridge, a design already known to be risky. For years, traffic had been increasing. The bridge was rated for lighter loads than it was actually carrying. Inspectors checked it visually. They missed the internal corrosion. On December 15, 1967, rush hour traffic filled the bridge. The crack in I-bar 330 propagated. The chain snapped. The bridge fell into the river in under a minute. 31 vehicles went into the water. 46 people died. Rescue divers worked in zero visibility. Some bodies were never recovered. Every bridge inspection program in America was rewritten after Silver Bridge. But thousands of bridges still operate beyond their design life. Piper Alpha was the deadliest oil rig disaster in history. A dead backup pump battery prevented the fire from being stopped. The Piper Alpha platform produced 10% of Britain's oil and gas. It sat in the North Sea 120 miles off the coast of Scotland. On July 6, 1988, a gas condensate pump failed. Maintenance crews had removed the safety valve for repair. A backup pump was available, but its battery was dead. Gas leaked from the unsecured pipe. It ignited in an explosion that blew through the platform. The fire couldn't be stopped because the pumps were offline. 167 men died, only 61 survived. Most jumped 175 feet into the freezing North Sea. The platform burned for 3 weeks. Every offshore safety regulation in the world was rewritten because of Piper Alpha. But maintenance shortcuts still happen on rigs every day. In 2009, an F-22 Raptor crashed because maintenance crews installed a wrong bolt during routine service. The F-22 was the most expensive fighter ever built, $150 million per plane, invisible to radar, capable of Mach 2. During routine maintenance at Edwards Air Force Base, technicians serviced a bolt in the flight control system. They used a bolt that was slightly the wrong specification. The bolt failed during a test flight. The pilot lost control of the aircraft. He ejected, but the plane was too low. He didn't survive. The Air Force grounded the entire F-22 fleet for 4 months. The investigation found the wrong bolt had been installed by a contractor following an outdated manual. The most advanced technology in the world is still only as good as the least attentive person who touches it. In 1978, a student noticed a math error in the Citicorp Center's design. The building was already finished and occupied. The Citicorp Center was a 59-story tower in Manhattan. Its most distinctive feature was the base. The building stood on stilts, with the corners hanging over the street. The structural engineer, William LeMessurier, had designed welded joints for the wind braces. The contractor changed them to bolted joints to save money. Nobody told LeMessurier. A Princeton student named Diane Hartley wrote her thesis on the building. She calculated that quartering winds hitting the corner, would create forces the bolted joints couldn't handle. LeMessurier reviewed her numbers. She was right. A centi-mass wind from the wrong angle could tear the building apart. Hurricane season was approaching. A secret retrofit team worked through the night for weeks. They welded steel plates over every bolted joint. The building was fixed. The public never knew until 20 years later. These events remind us that precision in measurement is crucial to prevent catastrophic outcomes.